Okay, hello, we're talking about the periodic trends, right guys?
Yes.
Okay, and we like, hey, these are kind of tough. The trend for atomic radius is not too bad. The trend for electronegativity is high to low, just like ionization energy. However, the ionic radius is kind of getting us a little bit down, isn't it? It's a little tough. So any ion below on the periodic table is bigger than the one above it. That makes sense because there's more energy levels, right? However, the ionic size is a little bit different. The general trend for atomic radius is to decrease. And why is that? Because the protons are pulling in the electrons, called the increased nuclear charge. So the more protons there are, they pull in the electrons. That's why the atom doesn't get bigger going across the row, across the period. So here's a little trick. I just write the number line. So each +1 and +2 +3, the general trend is to decrease, but cations lose their valence shell, so they're smaller. Anions, because of electron repulsion, they fill more electrons and they kind of bunch up and spread out. Okay, I know that's oversimplified, that's kind of what it does. So take this number line. Just, you know, in algebra, you need the number line, -3, -2, -1, 0, 1, 2, 3. Just do this, boop, and that's the size of ionic radius. The -3s are bigger than the +3s. I've been teaching 20-some years, and I found that, hey, this works. I never saw that before. So we'll see if anybody else likes this video. Okay, here's another picture. This is a picture I got out of a book somewhere. The ion smalls decrease. The ion size decrease for positives, then they increase for negatives, with a general trend going downward. So you can see how the negatives are bigger than the positives. So here's a better picture of this number line. Here's the number line, and all the negatives are bigger than the positives. So if you take the number line and turn it, that's the general trend for ionic radius. The -3s are larger than the positives, and the +3 is the smallest. And that's what this diagram shows right here.